So this is question number one. The question state if the water velocity in the bigger pipe is 3.05 meter per second, and the pressure is 414 kPa. The pressure here. Find pressure at point B. This is point B. This is point A. The frictional loss between point A and B is 7.62 meter. So the first step, we write the Bernoulli equation. PA over gamma plus V2A 2G plus ZA plus HPU equal to PB gamma plus V2B 2G plus with ZP plus HL plus HT. And then we cancel out the equation that we can cancel. So we can cancel the HT because there is no turbine in this diagram. We can cancel also the ZB because the ZB located at the lowest point. And then we can, because there is no pump in this diagram, we can cancel the HPU. From this equation, they are given the PA is equal to 414 kPa. This question asks about PB, which is we have to find the PB, but we are not given the velocity. To find the velocity at A and B, we are using the formula volume flow rate equal to AV. They given the VA, which is 3.05, so we find the AAVA first. Volume flow rate equal to, the diameter of A is 0.1 squared pi over 4 times with the velocity, which is 3.05. So we calculate, we get 0 0.2395 meter cubic per second. And then we get the volume flow rate. We can find the velocity of B. So volume flow rate equal to AB VV. So VV equal to volume flow rate over AB. Volume flow rate equal to 0.2395 divided by, we are given the diameter is 0.05, so 0.05 squared times with pi over 4, so we get the velocity of V equal to 12.2 meter per second. So we have all the velocity, the both velocity, so we just 414 gamma equal to this, velocity of A equal to 3.05 squared over 2 9.81 plus with ZA equal to, so here ZA is 9 equal to PB over 9.81 plus with the velocity of B, which is 12.2 squared over 2 times with 9.81. So HL, there is given HL here, which is 7.62 meter. So we solve this. So we solve on the the left. We get the 51.6759 PB 9.81. So at the right we get 15.29. So PB equal to, we minus this 51.6759 plus minus with 15.2, we get 36.4698 over 9.81. So we get PB equal to times 9.81 equal to 357.77. The unit is kPa. So this is the question 2. The diagram. This question 2 state the pressure gauge reaches 140 kPa, which is here. If the head loss along the nozzle is 2 meter, find the volume flow rate at the water flow. So before that, the first step, we should write the Bernoulli equation. P1 over gamma plus with V21 2G plus with Z1 plus HPU equal to V2 gamma plus V22 over 2G plus Z2 plus HL plus HT. So from this equation we can cancel some of it, such as first we can cancel turbine because there is no turbine on this diagram. Second, we can cancel the Z2 because the point 1 and point 2 is the lowest point. And then we can cancel the P2 because P2 is PATM, which means it's zero gauge. And then we can cancel the SPL because there is no pump in this diagram. And we can also cancel the velocity 1 as well because there is no velocity at the point 1. So the formula of volume flow rate is V dot equal to AV. And then after we cancel this, we rewrite it back. T1 plus Z1 equal to V2 2G plus HL. So from this we have known that V1 equal to 140 kPa. So 100 kPa over, because this is a water, 9.81 plus with 2.4, Z1 is 2.4 equal to velocity V2 to 9.81 plus with HL, the given which is 2 meter. From this we can calculate the V2. So first we calculate at the left. So we get 16.67 equal to V22 to 9.81 plus 2, so V22 can get 2 9, so minus 2 we get 14.67 into 1 2. And then you can solve the V22 equal to, calculate first, and then we get 287.848. The V2 equal to, we square root this, 16.966 meter per second. So volume flow rate equal to A2 V2. In this diagram, given the diameter of the nozzle is 0.05 meter, so volume flow rate equal to 0.005 square pi over 4. V2 we get 16.966. So volume flow rate equal to, we calculate 0.05 square pi over 4 times 16.966, we get 0.003 meter 0.030. The unit is meter cubic per second. So the third question is question 5. The question 5 is that the suction pressure at A, which is here A, is 6.8 MPa and discharge pressure at B, point B, is 3.4 MPa. If the oil velocity at point B is 1.5 meter per second, so the velocity at B is 1.5 meter per second. Find the power delivered by the pump into the fluid. So the power delivered by the pump, it's called the WP. Pump is 100% efficient, which is the efficiency of the pump is 100%. So the first step, we write the Bernoulli equation. PA over gamma plus with VA squared 2G plus ZA plus HPU equal to PB gamma plus with V squared B 2G plus with ZB plus HL and HF. So from this equation we can cancel the HT, HT because there is no HT on this diagram. There's no turbine. NHL, there's no stated HL in this information. There is no information about HL. Can cancel out it. And ZB you can cancel because the lowest point is point B. And that's all that we can cancel. This is the final equation. In order to find the WP, we need the HPU here. But before that, we have to find the velocity at velocity A. So we have to use the formula of AA VA equal to VV AB. So we have to find the velocity of A. So AB equal to AA VV. Now we know the diameter of the A is 2.54 cm. So we have to change it to the meter, so it will become 0. It will become 0. The diameter of B 5.08 cm. We have to change to meter, so it will become 0.0508 square divided by 2.4 cm. We change to meter, it will become 0.0254 square. And then we time with velocity of B, which is 1.5 meter per second. Right now we calculate the VA, and then we get VA equal to 6 meter per second. Right now, from this information, we got to know that pressure at A is 6.8 MPa, but we have to change it to kPa because this is a SI unit for this equation. So 6.8 MPa we change to kPa, it will become 6,800 divided by 9.81 times 0.9, and then the velocity of A 6 squared over 2 9.81. So we have the ZA here, which is 3 meter plus 3 with plus HPU, which we will find HPU. So the pressure at B is 3.4 MPa. We have to change to kPa, and it will become 3,400 kPa. And divide by 9.1 times with 0.9 plus with 1.5, which is the velocity of B, divided by 2 times with 9.81, and that's the equation. So we have to find the HPU. So the HPU here, then we calculate the left side here, and we calculate with the calculator, and then we get 775.024, and then at the right side we get 385.209, and then this going to this become subtract, and the answer for HPU is negative 3 at 9.815 meter. So the formula of the WP, since the efficiency is 100%, we use the formula of HPU times with mg dot g, where we can change the mg equal to gamma v dot. So we have the HPU, we have the gamma, but we don't have the volume flow rate. So we have to find the volume flow rate by using the formula V dot equal to A V. So for my case, I will choose the AA and VA. So volume flow rate equal to the area of the A, which is the diameter is 0.0254 squared, with time it's pi over 4, and then we time with the velocity of A, which is 6 meter per second. So we get volume of flow rate is 0.003 or 4 meter cubic per second. So this is the volume flow rate. Right now we can fill in the volume flow rate in here. Therefore WP equal to the HPU is 389.815 times with 0.9 times this 9.81 times with the volume flow rate, which is 0.00304 meter cube per second. When we calculate this, we will get 10.46 kilowatt.